Welcome to the Raw Coding YouTube channel. My name is Anton, and today we're going to be scraping cryptocurrency prices again. However, we're going to be doing it through WebSockets. Don't worry if you don't know what WebSockets are. That's why this video is here. We're going to learn about them. In the previous video, when we've been scraping cryptocurrency prices, we've seen how we only had a delayed price that only updated every minute or so. How about we try to receive the price as it updates, or maybe something closer to the live price? That is what we're going after today. Don't forget, if you're enjoying the video, like and subscribe. If you have any questions, leave it in the comment section, and don't forget to check out the description, visit the shop, and I also have a C# course out. If you're interested in that, I highly recommend you go and check it out. With that, let's go ahead and get started. Here we have our scraping project, and by the way, if you want the source code, you can get it from supporting me on Patreon. This time, instead of going to CoinDesk, we're gonna search for CoinMarketCap. You should be able to find a website that looks something like this. And if we take a look at the Bitcoin prices as well as everything else, things are not looking too good. But anyway, we want to open up the price, and if we just sit around for a couple of minutes, what we should see is the price is updating, and it's updating a lot more often than 1 minute. There we see it go again, so it's updating quite often. If we open up the network tab over here and we wait for another update, we're gonna see that no HTTP calls are being made. And you can see I have the all flag selected. So how is this price actually getting updated without any HTTP calls being made? This is where WebSockets come in. If I refresh the page, there's going to be a bunch of stuff that is loading. And if I go ahead and flip the status, effectively sorting all of the requests that have been made by the status number, we should see a 101. This is a WebSocket connection response, and you can also verify that the connection is basically still pending if you look at the time column. Here you should still see that the connection is pending. If we click on this latest, you will still have the headers tab, and it will look like a regular HTTP request, although the beginning starts with WSS. WS stands for WebSockets, and the second S on the end, same as in HTTP, stands for secure. That means it is protected with some kind of certificate, okay? What you need to know about WebSockets is it's established just like a regular HTTP request. The WebSocket connection and an HTTP request start the same way. You just go ahead and make a request to the backend, and then with HTTP, you get a response back. With WebSockets, that connection stays open. And then that connection channel is used to communicate between the backend and the front end back and forth. If we take a look at the messages, we're going to see that we're getting this arrow down, which is essentially pushing messages from the server down to the browser. And if we take a look at one of the messages, we can see that it is a little bit hard to read, or although from the previous episode we may see things like T may correlate with a timestamp, and then ID might correlate with the token, and then if we have something like P, perhaps that is the price. P24H we can say that that has to do something with the time format, right? Even though that the message is basically just abbreviations and stuff like that, you can get used to it and you can still read it, okay? Even though it looks like a jumbled up mess, it is not that horrible. Now, if I pull this down a little bit and we go all the way up, the initial message that we send when we establish the connection is this message to basically subscribe to some price, and then we say what kind of things we're subscribing to, okay? So what do we actually want to subscribe to? How do we send these messages, right? A bunch of questions that we may have at this point. First of all, let's just verify that we can get the latest price in these messages. If we scroll down, as this price is updating, we should see more messages coming in right at the bottom over here. If we go ahead and try to type out the latest price, so for example, 2902, we should see that an entry like this is over here with the decimal points on the right, okay? In here we have ID 1, and we can say that this ID perhaps correlates with the initial ID that we send over here. So data crypto IDs, the one over here, that's basically how we request for this connection to send us Bitcoin prices. With me guiding you, we essentially managed to deduct some of this information. Let's go ahead and try to figure out how do we do WebSockets connections. And just like any other developer, if you don't know something, you go to Google, okay? And that is what we're going to do. So Google, accept all of this, WebSockets, Python, and then you will be able to stumble upon this documentation over here. And there's a couple of things that you need to know about WebSockets. You can either be the server or you can be the client, same as with HTTP. You can either be an HTTP server or an HTTP client. If we come back to our project over here, when we're scraping the internet, so if we take a look at any of our scrapers, when we're using the get function, so this right over here, we're acting as the client, something that is requesting things. When we have our Flask API over here to act as a server that is triggering the scrapers, that is the server, and an initial request has to actually make its way there. The same thing is true for WebSockets. This is where we have to make a distinction. Do we want to act as a WebSocket client or do we want to act as a WebSocket server? And this WebSockets library allows you to do both. So you just need to be able to find the correct documentation, okay? If we spin up a connection like this, we will be able to send and we will be able to receive. In the second example over here, we will see that we are using the serve function on this WebSockets class to essentially spin up a server, which is then going to be able to accept messages and respond to them. We want to be the client, so we're going to grab this stuff over here, and we will also want to be able to install WebSockets. By now, you should already know that if you want to install something, didn't mean to click that, you want to do your pip install WebSockets. With WebSockets installed now, close this API stuff and we are going to add a new folder. I'll call it CoinMarketCap. Again, we will add a main.py in here. I'll just paste all of this code in here for now. I will then go into the shop main and just grab the default function with the args, close this off, place this here, and this is going to be the entry point to our spider. The actual place that we want to connect to, if we come back to CoinMarketCap, we'll grab this over here, place the URL somewhere at the top. So URL, string, take the URL, supply it over here. The initial message that we're going to send is if we go into messages and just grab this first message, we want to specify the data ID and method. So let's come back. We will place a dictionary over here and perhaps we actually want to verify. Can we just send dictionaries or does this have to be a string? And it looks like it has to be a string in this case. So let's actually serialize the dictionary to JSON. We'll say payload and then import JSON at the top. Import JSON. We will send JSON, dump, and payload. In the payload, we'll have data with whatever data we need in here. Then there was ID with whatever ID. And then there was something else which I can't remember. Let's go back in here, add method and subscribe. So let's say method, subscribe, ID was price, and then index is detail. So inside data, we'll have index, detail. We'll come back and then we'll have crypto IDs. Let me copy this key and place it over here. This is going to be an array, and in here we will just place one as we have identified this previously. With this, we should be able to receive some kind of message. If we come back over here, obviously, when I do something like this, I already have experience working with the WebSockets library. This is where I kind of have to say, well, if I never actually used the WebSockets library, what do? I would open maybe like a how-to guide, quick start, and then look through this. And I would see, okay, this is how you send. And if you're using the receive function, you get some kind of thing, and then you can actually print it. So let's actually do the same thing. We're using receive, we're waiting on it, and we're using this message. And I guess at this point, I've never actually explained what a sync and await is. We did go through the whole concurrency, threads, parallelism, and asynchrony. Async in this case, for those who've actually gone ahead and watched the stuff that we did with the parallel runners and stuff like that. If you want to skip this part, I'll put a timestamp in the description. Otherwise, I would highly recommend that you watch it. Basically, over here in this mess, what we're doing is we're submitting some kind of piece of work. So if we go back into BBC Food, collect recipes, we're yielding a task with this request. Inside next request, what we actually have is this get request, which is the thing that is going to take some time. Now, when we, not inside main, let me actually pin this window and we're gonna go into run, and let me pin run as well. Our executor is a thread pool executor. When we submit work to the executor, a thread inside the executor is going to try to run our task. So this is going to be our task and it's going to run it. And as the thread is executing, it is going to stop here, okay? If we make this async await, which is not possible, things have to be specifically made asynchronous and awaitable. In this case, this isn't, so we cannot actually do this. But if we could have done that, which we can in this case make things async and awaitable, what actually happens, the thread from the thread pool arrives here, and because there is going to be an await keyword, it can say, this is asynchronous, I don't need to sit here and block execution, I can go do something else. Now the execution may take something like 50 milliseconds in computer time. That is a lot of time for a thread to go and do something else. In our case, because we don't have an await, what happens is the thread comes in, blocks, and waits for the network driver in your computer to actually make the request to the internet, pull the data back, and then once it's received the data back, the execution carries on. If there would be, again, to reiterate, async await over here, the thread enters, the request is made, the thread goes, does something else. When the network card now knows that it has some information back from the internet or back from the server, it sends something called an interrupt back into the runtime of Python, and then Python is capable of saying, okay, let's take a thread from the thread pool and carry on execution from here. However, the requests library is not meant to work with async await because it's fairly new in Python. So we're going to remove this, and what we end up with here is essentially requests being executed in parallel, however, not to 100% efficiency, okay? So we'll close those two windows. Now that we are armed with that knowledge, what is happening is we declare an asynchronous function, and the await over here, whatever thread is going to be executing this, isn't going to block here and wait. If we have many asynchronous parallel tasks, at some point they will stop and start, resume, pause, etc. Whatever is running these asynchronous tasks is going to automatically figure out one thread goes here, starts, reaches the await keyword, resumes another task wherever it stopped. All of that hard stuff will be taken care of for you. And again, if you're confused, all you need to know is that async await just has to be used in certain places, and it will make your code run smoother, essentially, or more efficiently, right? Now that we have learned about that, we're going to reach the send function, we will send a message, and then we're going to wait to receive something. Let's go ahead and open up the terminal. I will clear. We will do scrape coin market cap. I don't think I need any parameters, and that actually didn't like it, because, well, we need some parameters, but there were none. So let's actually go down here to run scraper. When we're passing the rest of the arguments, we want to say if args, so if we have some, or let's say that length of args is more than 0. Otherwise, let's go ahead and pass an empty array so we can actually work with it. Let's reopen up the terminal, rerun the scraper. And there we have another error. The error here is with the dump method. As we have learned a long time ago, dump works with file streams and streams. Dump s, the s on the end, and load s means we want to work with a string, which is what we're going to have at this point. We're first going to have a dictionary, which is then going to get dumped to a string. Let's open up the terminal, run this again. And there we have it, essentially the same message as you would get somewhere over here. All right, let's come back and just make sure that we are capable of parsing this. So we're printing the message. If we get type and we put the message over here, again, rerun this, we just want to make sure that we're working with some kind of dictionary. And you can see that this is a string. So we're going to go to JSON, we're going to load a string message, and then we're actually going to get the data that we want. We can then map this to coin data equals some kind of new dictionary. And if I open up the terminal and scroll down so I can actually look at the data and map it across over here, we'll create a key like current price, and this is going to equal to data. There's a key D and then another key CR, and then inside there is P, which I think is the current price. That is on the CR object over here. Outside on the D, you have the T, which is the timestamp. Okay, so when we were scraping, where is it, CoinDesk on main, let's make sure that our data is consistent. We then also had time. So let's actually grab the time that we had over here, because again, this time is actually a string. Okay, so from the data, we will grab the D and then we will grab the T. This is going to return a string, which we will then want to convert to an integer. Okay, so a lot of stuff is happening over here. We will then also want to import date time. Let's go ahead, press Alt Enter or whatever it was. Let's import date time, and let's do from date time import date time, so we can work with the class directly. All right, if what's happening over here is a little bit too much, you can take about yay much the time format that we're seeing over here, or actually it was a little bit easier to see in the terminal, right? This is a Unix timestamp, so you can say Unix timestamp equals this, no semicolons in Python. We'll say Unix timestamp. We will bring up the terminal again, and we'll just need to double check that. Is this actually parsable? Do we need to divide by 1,000, right? So import date time dot date time dot from time stamp, and then supply the number. Looks like maybe we do need to divide by 1,000, and that looks good. And it actually seems like we don't need the rounding as well. So let's actually remove the rounding up. If we then come back over here, we will take a look at the ID. We know that ID 1 means that it's Bitcoin, and we will just create a simple mapping. So this will be an ID coin underscore map. 1 will map to BTC, and here we can say name or anything that you want. So ID coin map. From data, we want to pick the ID. Let's open up the terminal, just verify that that's where it is. We don't want this ID, we want the ID from DCR and then the ID here. So let's just pick about yay much and replace this data with that. So DCR, we're getting ID, comma on the end over here. And that looks good. Let's grab coin data, print it, open up the terminal, and I'll actually need to exit from here. Rerun the scraper, and that looks pretty good. Now what we can do is actually place a while loop and listen to this infinitely. So while true, let's indent all of this. Again, open up the terminal, rerun. I'm probably gonna cut the video here so we can actually just see a couple of things printed to the console. And there we have it. We can see that the interval is a lot better. We can see something like 5 seconds. Sometimes it's a couple of milliseconds. Sometimes it's like 4. No, that is still 5 seconds. Yeah, basically you can see you're getting price updates a lot more often. Whatever trading strategy you have, you can go ahead and apply it. Now, the way that we exit this is we have to press Ctrl+C because it's essentially an infinite loop. Again, same as the previous video, because this is sort of like an ongoing thing. If you're going to be building a trading bot, you constantly want to be grabbing this data. So what I'm going to do is say put an incrementer, and the incrementer will start at 0. I will put I over here, and same as before, I'll just say run up to 20. I will also have the results over here, which is just an array. And then into the results, I will append the coin data. I'll remove this. And by the end, we will just increment I plus 1. I know this could be slightly annoying when whatever I'm typing is down here, so I'm just put this in the middle, and at the end let's return the results. Open up the terminal, rerun, and let's wait for the data to come in. I'll actually remove whatever we have here in the output, close it off. And one thing I realized, I'm not actually returning anything from default. So let's go ahead and make sure that we do. If we hover over hello, we'll see that the return type is coroutine any list. I know for some beginners that this may not mean much, but if we hover over run, the thing that is accepts in the main as the first parameter is this coroutine of any and this t at run. So whatever our function is going to return here, that's just going to be returned from this run function as well. So right over here. Basically, all this means is we just want to return whatever is going to be returned from this function. And by the way, you can see how we're not awaiting here. This is why our scraper actually stops here, pauses, and then whatever actually runs inside here runs efficiently. All right. Again, let's open up the terminal. Let's rerun, and I'm going to cut over here. Looks like that is now finished. Let's take a look at the output, and it looks like we have some data. I'll be honest, looking good. The last bit of concern between the previous video and this video is, dude, I am building a trading bot. Why do I need to sit around for this loop to go in circles and wait for the price? Can I not consume the data as it is coming in? We are in the same situation in this case as well. We're just looping over a bunch of times, and in fact the loop starts over here. Can we not get somewhere in the middle of this, right? So instead of just appending results to this array, can we not just listen in or receive this or stream this, generate these values, right? Any of those words, of course we can. This is one of the funnest parts to figure out. How do you build a data pipeline? You have a lot of data coming in. You don't want it to be a big ball of mud. You want to take bit by bit, send it off, and the data travels through your pipeline however you want to build up your pipeline. And that is something that we're going to take a look in the next video. For now, this is going to be it. Thank you very much for watching. If you enjoyed the video, don't forget to leave a like and subscribe. If you have any questions, make sure to ask them in the comment section or come join me on my Discord server. If you want the source code for this video or any of my other videos, please come support me on Patreon. It helps me a lot making these videos, and a very, very big thank you to all of my current Patreon supporters. Your help is immensely appreciated. As always, thank you for watching, and I'll see you in the next video.